Have you ever marveled at how a robotic arm can precisely pick up a delicate object or perfectly weld a complex seam? This seemingly effortless precision is not magic, but the result of sophisticated calculations that are fundamental to its operation. It is about instructing a robot what to do with its hand, and then letting the robot figure out how to move its arm. Inverse kinematics fundamentally impacts robotic control systems by providing the critical mathematical bridge between a robot's desired end effector position and orientation in space, and the specific joint angles required to achieve that pose. This capability is absolutely essential because it allows robots to perform tasks in a human-intuitive way by specifying where their hand should go rather than meticulously dictating each individual joint movement. The why behind this impact lies in the nature of robotic manipulators. A robot arm is a series of interconnected links and joints, similar to our own arm. Forward kinematics easily calculates where the end effector will be given a set of joint angles. However, for practical tasks, we rarely know the exact joint angles needed upfront. Instead, we know where we want the robot's tool to be in the world. Inverse kinematics solves this complex geometric problem, determining the configuration of each joint required to reach that target. This involves solving a system of nonlinear equations, which can be computationally intensive and often yield multiple possible solutions. For robotic control systems, this means instead of teaching a robot every specific joint rotation for every point in a path, a programmer can simply define a desired trajectory for the end effector. The inverse kinematics algorithm then continuously computes the necessary joint commands in real time, feeding these values to the robot's joint controllers. This allows for dynamic path planning, obstacle avoidance, and precise interaction with the environment, vastly simplifying programming and increasing adaptability. One key insight into inverse kinematics is the concept of a singularity, which occurs when certain joint configurations cause the robot to lose degrees of freedom. Imagine stretching your arm out fully. You might lose some flexibility in your wrist. Similarly, a robotic arm in a singular configuration cannot move its end effector in certain directions, regardless of joint velocities. Advanced inverse kinematic solvers actively manage or avoid these singularities to maintain smooth and controllable motion. The ability to handle redundancy, where multiple joint configurations can achieve the same end effector pose, also provides flexibility for obstacle avoidance or preferred postures. Ultimately, inverse kinematics transforms robot control from a tedious joint-by-joint orchestration into a more abstract and task-oriented approach. It empowers robots to be adaptive and precise, enabling them to navigate complex workspaces, interact safely with dynamic environments, and perform intricate tasks with the agility we expect from modern automation. This foundational understanding is key to designing and deploying effective robotic solutions.
If you love robotics, like, subscribe, and keep building with us.